All right, we just came from configuring the RIP version 2 dynamic routing protocol. The next routing protocol we're going to talk about for this particular certification, the CCNT, is OSPF. This comparison table is going to show us, okay, the differences between both and what will be the advantages and disadvantages of using one or the other. So you can see that OSPF versus RIP, one's a link state routing protocol, the other one's a distance vector. I already said that a distance vector sends out the routing updates every so often. Every 30 seconds, 90 seconds, you can tweak it. A link state routing protocol actually does triggered updates. Only when there's changes that it does send any kind of updates out. Only the first time. Then when an OSPF is starting to recognize all the different routers in this particular area, that's when what is called link state advertisements get sent out completely. But after that, it just changes. Now, they both support classless support, which means that you can have variable length subnet mask throughout your network, and it will support that. That's why you see VLSM. So classless, VLSM, pretty much the same thing, okay? So they both do support that. Auto summarization, OSPF does not do auto summarization. You would have to literally do it yourself. But by default, version 2 does auto summarize. That's why we have to do no auto summary, which we don't have to worry about in OSPF. So yes, we need to do manual summarization. Does it support non-contiguous? They both do. We just did that. When you see, like we had a class C address at the bottom for your LANs, I should say, and a class A at the WAN portion of it, meaning between routers, that is not a contiguous network. It is a non-contiguous network. So they both do support that. Route propagation, again, multicast on change, and periodic for RIP version 2, multicast. They both do multicast, but one's based on change, the other one is based every so often. Now, the path metric. How does it know which way to go? OSPF is a very intelligent protocol because of the algorithm that it uses. So it does pay attention to many things. One of the main things that it looks at is bandwidth. So it does analyze the lines to say, hey, which would be the best way to get to a network? But RIP really doesn't analyze the lines. It just says, hey, which is the shortest way? Because that's what distance vector is, distance and direction. So it just says, well, if it's a straight line, doesn't matter that it's a dial-up and you have fiber optics on the outside using OC152s. It does not matter. It just sees a straight line, shortest path between 2 points, right? So it says, I'm going this way. Regardless, it could be bogged down. It doesn't really care. So RIP does not do any kind of analyzing based on its algorithm. It just says, hey, which is the shortest way to get there? Where OSPF doesn't do that. It actually makes a mathematical calculation to make a proper decision on which way to go, or a more efficient decision on which way to go. Doesn't stop there, though. Hop count limit, OSPF has none. It has no limit. It has no real limit. I would say you could put a limit on it because you don't want to make it too big in an area, but there is no limit. There's no unreachable, where RIP is for very small networks, 15 routers at the most. So with RIP version 2, besides that it sends periodic updates, it's limited on the amount of routers you can have. Convergence, OSPF, it is very quick. And compared to RIP, RIP is slower than OSPF. Peer authentication, they both do it. Okay, so that's good. They have a secure when they're talking between each other. And there's a hierarchical network requirement, yes, for OSPF, but only, and again, this goes beyond the scope of this certification, but when you use multiple areas, because OSPF is based on multiple areas. Where RIP, no, RIP is just a flat routing protocol. It doesn't matter how many routers you have. Remember, it really doesn't pay attention to the line or the design of the network. It's just going to send it based on how many hops it needs to get to that destination. But again, multiple areas are something that you won't see until you get to your CCNP level and above, but we'll mention it later on as we go through OSPF. Mention it, not really get too deep into it. Again, updates are based on triggered events with OSPF, where RIP version 2 is periodic. Now, the algorithms. I kept mentioning the algorithms. Definitely for OSPF, the algorithm is the Dijkstra algorithm. All right, and for RIP version 2 is Bellman-Ford. The Dijkstra is way more complex than the Bellman-Ford, and it does take care of a lot of issues between the other protocol, which is EIGRP, the dual. So it does take a look at it, not to get into the physics of it. All you need to understand is, hey, this is the algorithm that OSPF uses. This is the algorithm that RIP version 2 uses. If asked on a certification, you would know. But based on all these things, definitely OSPF would be a way to go, a deciding factor if you're going to have a very large network, since you can create a hierarchy of different areas. So this is why you would choose one over the other.